Hey folks, we are focusing on density here. So, density is composed of two specific factors. We have mass, which we should remember is the amount of matter within an object. And it's a little bit different than weight, because weight is how an object's mass is affected by gravity. And volume is the amount of space something takes up. So density is really how much stuff you put into a specific amount of space. Now, density is what we call an intrinsic property. And let's see, can I zoom out here? View, zoom. Great. So density is what we call an intrinsic property. That's a property that never changes. So other intrinsic properties would be melting point, boiling point, freezing point. No matter how much of something you have, the density never changes. So it's an intrinsic property, and you can use this to identify what something is. I don't know why I made that capital. Identify a substance. Now, the calculation for density, the formula for density, is going to be density. I'll put it right over here. Down here? Down here is good. You can't see that too well. Let's use this one. That one either. Oh dear. I need a nice light color. Let's pick one. Like blues. That's still not very visible. Ah. That's visible. Density equals mass divided by volume. That's often written just as D equals M over V. So D is for density, lowercase m for mass, and a V for volume. Let's give this a try. Let's try the problem and see what we can do. Remember to always use units. Always, no matter what. Just going to come down about that far. And let's say, let's see, pick out a nice color. I see the issue is too narrow. That'll be better. We have something whose mass, I do want that in there, So the mass is equal to 453 grams, and the volume is equal to 225 centimeters cubed. Now, centimeters cubed, what that means is if you have a cube, you would measure it in one face, one angle of it in centimeters. But for each dimension, you have to multiply it by that number of centimeters. So for one dimension, it's centimeters to the first. For the second dimension, that is another centimeters you have to multiply by. And then for the third, you have to multiply those all together. When you do that, you get centimeters cubed. Makes sense because this is a cube. And it takes up space. So, what we do, one of the first things I always do when I have a problem to work on is I identify what my variables are, and that's what these are. These are my variables. And then I apply them to my formula. So, density equals 453 grams divided by 225 centimeters cubed. Go ahead. This is a good time to pause. There's your pause button. And I'll math this out while you do. Alright, you should have come up with 2.01. And then it's like 3 repeating, but we'll just leave it at 1. Now we use the units from the equation, and what we're going to do is we are going to go ahead and just take these units here. So it's going to be grams divided by centimeters cubed. And this is our answer for this one. Let's see. Let's do another one. Here's a good one. A cube has a mass of 1,450 grams. It displaced 542 milliliters of water. Find the density. Now y'all should be able to find the density of this one. And I don't know why they had to use the water displacement method for a cube, and they can just measure one side and then cube it. But hey, live their dreams. Now this is your chance to pause and work out the answer yourselves and figure it out but actually, before you work it out, make sure you do all of the work that you would put down here so that you have it to go off of. And I'll show you what I would do once you're done. Oh, fun fact. 1 milliliter is the same as 1 centimeter cubed. Just so you know. All right, let's go ahead and hit this. So we have our mass is equal to 1,450 grams. Our volume is 542 milliliters. Density equation, set it up. 1,450 grams divided by 542 milliliters. When you work out that math, it comes to about 2.68 grams per milliliter. Units are always extremely important in this. Now, what if let's see. What if let's suppose you order a let's suppose that for some kind of construction job, you're ordering a bunch of iron. And you decide to order, let's say, 700 and I will say 7,462 centimeters cubed of iron. Which is a ridiculously small volume of iron to order. That's only 7 meters cubed, but whatever. How much should it weigh? What should be the mass? Is considering that iron's density of 7.87 grams per centimeters cubed. This is a tough one because instead of giving you volume like I did before, I've given you density and... No, I'm sorry. Instead of giving you mass, I'm asking for mass. Okay? So let's point out a few things. Right here, we have our volume. our mass, we don't know. We're trying to solve for the mass. I always want to try to find out what you're trying to solve for early on so you know what you're working towards. And our density, oops, is 7.87 grams per centimeters cubed. Now, we can do some fancy math and all that, but it's easier to start the equation from an easy setup. So let's take a look at our equation. D equals m divided by v. Density is mass divided by volume. These all have a relationship that doesn't change depending on how the equation is organized. So we are just going to go ahead and reorganize the equation. Now we want to get mass alone. Okay? So our goal, get mass alone. So to do that, we're going to take V and put it on this side somehow. To do that, what you want to do is multiply both sides by volume. Now, this is going to do something great for us. It's going to cancel out volume on the right hand side and put it on the left. But because we did the same thing on both sides, the equation doesn't change. We can do this. It's something you would do commonly in algebra. So now the equation we're using is VD, volume times density, equals mass. So take a minute, pause here, and solve for mass. All right, now what's going to happen is 7,462 times 7.87. It's going to give us that much. It's going to give us not another 7. It's going to give us 58,725.94 grams. And because we are multiplying centimeters by centimeters, they're going to cancel it out. So if I did this in a way you could more easily see, let me set this up again. If I set this up this way, because I'm going to do the same equation again. No, that's not going to be enough space. I hate when I do that. Don't you? I sure do. Seven, 462 centimeters cubed. If I turn this into a fraction, that's just over 1 times 7.87 grams over 1 centimeter cubed, because the centimeter cubed is at the bottom of a fraction, equals mass. So what happens is the centimeters cubed, because they're on opposite sides of the line. What's the name for the fraction line? Goodness me, I can't remember. Anyway, because they're on the other sides, one's a numerator, one's a denominator, they cancel out. Why is my mouse right in the way? That's annoying. They cancel out, leaving us with grams for our mass. So you end up with 58,725.94 grams for the mass. That's going to be a heavy block of iron. I don't care who you are. Let's do something similar. And yes, something similar. Let's see. We have. Green's a nice color. Although. Let's do that. Okay. Let's say you have how much space should a 500-gram gold bar occupy? Density of gold is 19.32 grams per milliliter, or centimeter cube with that. Oh, great. I hope that text isn't too wonky for y'all. I had fun with it. So we have our... I can't use that. That would just be mean. So we have our mass. Mass is 500 grams. Volume is unknown. And density is 19.32 grams per centimeters cubed. On the last problem, we figured out that we could rearrange our equation to VD equals M. How would you rearrange it this time? Go ahead, take a pause, and see what you can figure out. Alright, what you would do this time to get volume alone is get density to the other side. So now we divide both sides by density. And now density has moved over to be with mass. So the new equation we're using is volume equals mass divided by density. So go ahead, calculate out the volume. I'll do another pause. And we'll check it. Alright, so what you should have gotten was I'm just switching the sides of the equation. It's the same thing. So that mass and density are on the left instead. 500 grams divided by 19.32 grams per centimeter cubed equals volume. Is going to give us 25.88 centimeters cubed. And honestly, that's small enough to fit into most of our not test tubes, graduated cylinders. That's it. Now, let's take a look at something a little bit different that is still applicable. Honestly, you might have done when you were kids. When you have liquids that have different densities, they will form what's known as a density column. And actually, they can be used in an interesting way to identify the density of different materials. But let's just go into this for now. Let's say that you have some density columns, and we have 3 liquids. We have Karo syrup, which we'll label K, with a density of 1.4 grams per milliliter. You have vegetable oil, at 0.91 grams per milliliter. And you have water. I feel like red is not an acceptable color for water. I just can't have water be red. I just can't. It doesn't work, okay? That's just how it is. I don't make the rules. Which is 1.0 grams per milliliter. So, let's suppose we have 3 columns. Number 1. Let me see there. Number 2. As you can tell, I'm very good at drawing columns. And number 3. All right, and these are just examples. I want you to tell me which one is correct. We have in the first column Karo syrup on the bottom, and then we have water above it, and then above that we have vegetable oil. In the second one we have vegetable oil, then Karo syrup, followed by water, and in the last one we have water followed by vegetable oil, followed by Karo syrup. Now, which one of these do you think would be correct? Take a minute to think about it before I give you insight on how to solve this. All right. When you approach these kinds of things, you have to remember that, well, you have to know, not remember, you just have to know that something with a higher density will sink below something with a lower density. So the Karo syrup, having the highest density, would be at the bottom, followed by water, followed by vegetable oil, meaning that number 1 is the correct answer. Now, let's actually zoom in on... let's get rid of the other two. I just want them gone for now. And let's consider if we had something that, if we had an object like a red ball with a density of 1.2 grams per milliliter. Well, this red ball, having more density than the vegetable oil, having more density than the water, but less than the Karo syrup, would sink below the vegetable oil and water, but float on the Karo syrup. So it'd end up right about there. If you had a green block with a density of small number 0.95 grams per milliliter, it has a higher density than vegetable oil but a lower density than water, so that could float in between those two. So this can give you a comparative idea of different densities. Let's see, anything else? No, that is about it. Alright, that is a half hour. That is way more than I wanted, but I hope that this gives you some insight into density and will help you understand it better when you take your notes. Best of luck. And all, goodbye.